A meteorologist is someone who studies the weather. When we study the weather, we take into account temperature, moisture, pressure, precipitation, rain, snow. We look at the clouds, anything and everything that happens outside pretty much. We forecast what's going to happen with the weather, and it's something we look at all the time. It's a job that takes someone 24 hours a day, 7 days a week, 365 days a year looking at the weather. In a typical day of work, I come in, I sit down in front of a computer and start looking at everything that I can. I look at the satellite imagery, I look at radar, I look at observations from those computer-generated observations. I look at what's currently in the forecast, and then I look at computer models. Information comes from satellites, from radar, from computer models that ingest data. We release a weather balloon at least twice a day. Releasing a balloon gives us the opportunity to get live data. It's not just what the model's saying, we're seeing what's actually happening. A weather balloon is basically a very large balloon, and it will start out about 5 feet in diameter, 5 feet across, and 5 feet tall. And it has a small parachute underneath it, and then a very long piece of string attached to a little instrument pack, the radiosonde, with different instruments on it. And that radiosonde will feed us back temperature and moisture and pressure information that we can plot up on a graph, and from there look and see what we think is going to happen. We can look at wind, we can look at stability, we can look at where we think the clouds are going to develop. As the instrument collects data, it sends back a signal through the small antenna on the radiosonde and sends it back to computer. It'll give us the raw data. And once the data comes in from the weather balloon, it will go into a computer and will come out, and we'll just look at the columns of information, a lot of numbers. Now, the computer has the ability to graph these numbers. It can plot temperature versus height. It can plot moisture. It can plot pressure. I look at the data and then I think about, is this realistic? What is this data telling me? I can look at lines on a computer screen or images that are in front of me, but I have to know what they mean. Right now I'm looking at surface data. I'm trying to examine relative high and low pressure systems, and that's a lot of what dictates our weather from day to day. Math is probably the major basis of what we do each day. Numbers will go into equations, and I have to look at the numbers. I have to compare the numbers. I have to be able to put the numbers in a pattern. And from there, that tells me what's going to happen, say, later on in the day, tomorrow, next week. These brighter red colors are more the dry air, and what you see in the white or the gray is more moisture, a lot of it's clouds. These little pixels up here that are in more the pink color are actually lightning strikes. Nothing in weather is for certain. We deal with a lot of chances. We deal with, is it more likely or less likely? It's not a heads or tails, flip a coin, is it going to rain, is it not going to rain? There are so many different aspects that we have to take into account. The weather person says that there is going to be a 30% chance of rain. What does that mean? Well, it means that 30% of a certain area will see rain. If you are looking at a circle of area, 30% of that, 3/10 of that, will see rain. The rest won't. We have to look at various types of data, models and satellite. Then we start looking at, well, if I've seen this before, last time I saw this, what happened? And use that, and we just basically go into a pattern. And we look at what the pattern tells us. It can be simply as 1, 2, 3, 1, 2, 3, or it might be a more complicated pattern that would take you longer to look at. We use several different types of math. We use basic addition and subtraction. We use comparison, high number versus low number. We use percentages, which can be algebra, so it can be basic math of multiplication and division. We use geometry, looking at the speeds and direction of a feature. Most meteorological concepts can be explained through some form of math equation, and most of the time that comes in the form of calculus equation. I'll use fractions, I'll use percentages, I'll use ratios, I will use geometry. The standard, if a train leaves from point A and it wants to get to point B, when is it going to get there? Well, that's what we do every day. We look at a storm, say, in Texas, and we see when it's going to get to Washington, D.C., to anywhere else in the country. You can take, for instance, a hurricane. A hurricane tends to have, in general, a certain track. It'll start out in the south. It's a pattern that it follows. And we have to look at that, and that's a lot of what forecasting is recognizing the patterns and being able to take the next step. And that's how we tell what's going to happen. But I was always the kid who enjoyed the thunderstorms coming through. I'd love to look outside the window and watch lightning come in. I grew up on the Gulf Coast, so hurricanes were usually a factor during the summer. It's not something that gets boring every day. You're never going to come in and have the exact same routine every day. Something is going to be different. Once you start learning some of the aspects of weather, the type of clouds, the wind, humidity, things like that, you kind of look outside and see things differently. So it just kind of gives you a different awareness. In high school, I decided to do several different internships to decide what part of meteorology I wanted to go into. In college, I took meteorology classes, and it turned out that I really enjoy forecasting. I like trying to manipulate what the computer's telling me versus what is going on to what I think is going to happen. I'm never ever bored looking at something involving the weather. There's so many fascinating parts: storms, hurricanes, and lightning, and hail, and snow. One thing that we have to always remember as a meteorologist is to be aware that weather not only affects us as a hobby, but it affects everyone else. We have to worry about people who are outside during a thunderstorm. We have to make sure that they're prepared for really bad weather, say a severe thunderstorm, a tornado or a hurricane, a snowstorm or a flood. We have to make sure that people are aware of what's going on. That's why we want to know as much as possible about what's going on and be able to warn people. So as long as we save lives and protect people, that's probably the most satisfying part.